Hello, everyone. This is an visual representation to KNOW about Newton's law of viscosity and types of fluids.
So hello everyone, myself Supratim Roy, and today I'll be discussing a few topics of fluid mechanics, that is mainly Newton's law of viscosity and different types of fluid. So in this presentation, we'll discuss about the fundamental concept of fluid mechanics, we'll dive into definitions and types, and a few applications of these topics we'll discussing the real life application. So let's get started. So before jumping into Newton's law of viscosity, let's understand the concept of viscosity. So viscosity represents a fluid's thickness, that is a measure of its resistance to flow. It also defines how fluid flows over surfaces, dictating the behavior and influencing critical engineering applications. Let's think of honey and water. Honey has greater internal resistance, that's why it is more viscous. So taking further that example of honey, you remember the last time you had a bottle of you used a honey bottle for some green tea or maybe something else. So when you poured honey, it took a long time to come out from the bottle, right? Why? Because it has a great internal resistance, which solely is the main property that is called viscosity. Next, now let's get to the main topic, that is Newton's law of viscosity. Newton's law of viscosity is a fundamental principle in fluid mechanics that describes the relationship between shear stress and shear rate of a fluid. It also plays a very crucial role in understanding and predicting the behavior of fluids in various engineering applications, which we'll be taking note in the further slides. So let's see how Newton established this law of viscosity. So in 1687, Sir Isaac Newton introduced this concept of viscosity in his seminal work, that is Philosophiae Naturalis Principia Mathematica. So after almost 2 centuries later, Gottlob Weidmann conducted experiment to quantify the relationship between shear stress and shear rate, which ultimately laid the foundation for Newton's law of viscosity. And now that not now actually in 1900, the term viscosity is formally defined and the relationship is widely adopted in field of fluid mechanics. So let's look more into Newton's law of viscosity. So the shear stress is the force per unit area acting on a fluid which ultimately deforms or flow. And shear rate is the rate of change of velocity of a fluid perpendicular to direction of flow, right? So its relation is that Newton's law states that shear stress is proportional to shear rate, with a constant proportional being the dynamic viscosity. So let's say the x-axis is the shear stress and y-axis is the shear rate. So it is proportional and the graph will be linear, right? So this was all about Newton's law of viscosity. Now, the types of viscosity. There are mainly two types of viscosity. One is dynamic viscosity and another is kinematic. Dynamic viscosity qualifies a fluid resistance to flow, measured in Pascal second. And kinematic viscosity is the dynamic viscosity divided by fluid density, which is expressed in meters squared per second. So this was all about viscosity. So this was all the definition and the theoretical part. Let's move on to some application where this law is being applied in real life scenarios. So myself as a mechanical engineer, there are a lot of use in it. So viscosity is essential in designing machines. It is very important, particularly those operating in marine environment. The machines which are used in and out the fluids like the submarines and all. And next is lubrication and pipelines. Viscosity plays a significant role in determining the forces required to overcome the friction when fluids used for lubrication or transported through pipelines. Next is the heat generation. Viscosity influences the generation in bearings, cylinders, and gear sets due to internal friction of the oil. So this is some of the few applications of viscosity, and this is where my viscosity topic ends. And let's move on to different types of fluid, that is exploring the realm of fluids. Here we will be understanding the properties and behaviors of fluid in various fields like engineering, physics, and in everyday life. So without any delay, let's move into the topic. So first one is real and ideal fluids. What are ideal fluids? The word itself says it must be perfect. So this fluid is incompressible and zero velocity. So it is mainly a theoretical concept, so no ideal fluid exists in real life. But in some cases, like a real fluid flowing past and around a stationary object, ideal theory works well outside the boundary layer. Next is the real fluid. This fluid is incompressible and velocity is present, which is found in nature like air, water. These all are real fluid. When you look around, you see the real fluids. Next is Newtonian and non-Newtonian fluids. So in Newtonian fluid, shear stress is directly proportional to velocity gradient. In non-Newtonian fluid, shear stress is not proportional to velocity gradient. Water is an example of Newtonian fluid, and honey is an example of non-Newtonian fluid. Next, that is the last part, that is the ideal plastic fluids. So this one is an interesting one because it has three main things to look around. It is yield stress. Yield stress is where the flow begins when shear stress exceeds a critical yield point. Here, the shear stress exceeds a critical yield point, that is the yield strength. Next, when the yield point that is present in the graph, let's say we made an imaginary graph, when beyond the yield point, shear stress is directly proportional to the shear strain, which ultimately leads to some Newtonian-like behavior, which is the third point. So it exhibits a linear relationship between shear stress and shear rate, which is the main property of the Newtonian fluid. And as we move on to the examples, it will be much clearer. So these are the examples of ideal plastic fluids. So the sewage sludge, like the human waste that is being dumped in various parts, this is an example of ideal plastic fluids. And when you wake up in the morning, the first thing we search for is the toothpaste, and that is the ideal plastic fluids. So I guess I explained the topic well as much as I could. So that's where my presentation ends. Thank you for watching.